Section 5.3 Properties of Logarithmic Function. So in section 5.2 we define logarithmic function. In this section we're going to talk about different properties of logarithmic function, especially product, quotient and power properties of logarithms. And using those properties we try to write down logarithmic expression in an expanded form, and sometimes we try to combine the different logarithmic expression as a single logarithm. And finally our goal is to solve log equations. So these are the three properties. Let b, x and y be positive real number such that b is not equal to 1. Then the first property, which is the product property, log base b of x times y. Remember, this log function is the completely new function. So whenever we try to deal with this function we need some rules, and these are the rules. So log base b of x times y, which is a product between x and y, is equal to log base b of first term x plus log base b of second term y. Here you see the product property just for the two terms x and y, but we can apply this product property for as many terms as we have. For example, let's say if you have x, y and g, then you can replace, you can expand this product property for three different terms. The second one is called quotient. If you have to apply the log function for x quotient to y, then we can expand this as a log base b x minus log base b y. And then final property here is power property. So if you want to find out log base b of x to the power p, then we can bring this p in front of log function. So it would be p times log base bx. So these are the three properties. Remember, we can go from left to right. We can use this property from here to here, or sometime based on the problem we can also go from right to left. So that depends on what we are asked to do. Okay, so let's see some examples. Use the product property of logarithms to write the logarithm as a sum, then simplify if possible. So log, it means log base 10, and there are three terms, 2 times x times y. So we can use this product property log. So remember, product property means log base b x times y times z times whatever, how as many terms as you have, just expand them in terms of log and then apply the product property. So you just have to replace that by plus. So there are three terms, 2 times x times y, so it would be log 2, log x and log y. That is the expanded form. So here there are two terms, 3 and a plus b. A plus b is a single term, so we can expand this as a log 3, which is ln 3 plus ln a plus b. There is no rule which can be used here to expand this a plus b. Okay, so that is the most we can do. Next problem, use the quotient property. So quotient property is log base b of x over y. If you see the division inside this parenthesis, we can apply this log property, and which can be replaced by minus sign. So here it's log base 7 of z minus log base 7 of 49. So for the first term we cannot do anything because that's a simplified form, but for the second term we can write down this 49 as a 7 square. So now they have the same base. So by using the basic property of log function, if they have log base 7 and there is a exponential function with the base 7, then using the property of the log and exponential, it can be replaced by 2. That 2 is coming from this exponent. So that is the most simplified form. For this one, log 100 minus log x plus y. Remember, log means log base 10. So this can be written as 10 squared minus, there is nothing we can do here for the second term. And either you can use a calculator for finding the log base log 100, or you can just say that because log has a base 10 and 10 square is there, so we can use the property of log function, and we can write down this as 2. That's the simplified form. Okay, we use the power property of log function. The power property means if you have log base b of x to the power p, whatever power, you can bring that power in front of that log function. So here our log function is ln, so we can bring that power 5 in front of log function. And that's the most we can do. And here ln means actually it's a log base e, and there is e to the power 5. So this is basically 5. Or what you can do is you can bring this 5 in front and you can write down ln e, and we know ln e means 1, so 5 times 1 is eventually 5. So in both way you are going to get 5 as answer. So so one more problem, we have to write down this expression as a sum or difference. So first of all, because there is a quotient sign, so we can use the quotient property, log base 3 of 5z minus log base 3 of w. And since there is a 5 times z, we can use the product property. So we can write down log base 3 of 5 plus log base 3 of z minus log base 3 of w. And that's the most we can do. That's the most simplified form. Here we can use product property, and we can write down ln x squared plus ln y. And since there is a power, so we can use the power property, and we can bring this 2 in front, and that is the most we can do. So write the logarithmic expression as a single logarithm with a coefficient of 1 and simplify as much as possible. So this time we want to go from the from right to left while using that product quotient and then power property. So as you can see that there is a two log function, log and log, and in between them there is a minus sign. And also remember, this log function have the same base 10, so we can use the property that's a quotient property, which is log 4x minus 3 over x. Okay, and we know that there is a 1 in front of log, so that's the coefficient 1, and that's the most simplified form. There is nothing we can do. We cannot just cancel anything here, so that's the most we can do. Sometime we need to change the base, because on we need to find out the log function for different numbers, different value. And for finding the log function, there is a in your calculator there is a tab for log, and there is a tab for ln, so you can find out the value of this log function for different number. But it's difficult to find out the value of the log base, different base, so we can change that base by using this formula. Log base b can be written as log base a means the base of your choice, but you need to divide that by log base ab. So since the ln and log are so popular, so we can change that log base b as a log x over log b, or ln x over ln b. One example is, let's say you want to find out log base b 5 of 10, then instead of finding that, you can just type on your calculator ln 10 over ln 5. Okay, and that will give you the answer. For example, here you can find this by log 15 divided by log 7. I will let you type this number, this value on your calculator, and just find out up to 4 decimal place. Here it's a log 0.3 over log 5. Remember, either you can use log or you can use ln. Both gives you the same thing by using this change of base formula. Okay, so just type this number, this value on your calculator, and find out the value up to 4 decimal places. Now it's time to solve equation using this log property of equality. So if you have log base a of some expression x on the left side, and then some on the right side you have the log base very same a of some expression y, that is only possible if this value x and y are equal. Okay, so we're going to use this and if this thing is equal, then that means it implies x and y should be equal, and if x and y are equal, then it also implies the log of x, log base a of x is equal to log base a of y. Okay, so let's try to solve that this equation by using the log properties and log equality properties. But for that we need log on one side with the base, with a base, and then log on another side with the same base. So for that you can see on the left side there are two log, so we need to combine them and express as a one single log, and on the right side there is just only one log. But before that, before solving this log equation, you always have to find out the domain of the function, the log function you are using here. So for the first one there is x plus 5, so x plus 5 has to be greater than 0. So that means for the first function x has to be greater than -5. For the second one, x minus 2 has to be greater than 0. That implies x has to be greater than 2. And for the third one, 2x plus 2 has to be greater than 0. If you try to solve it, it said x has to be greater than -1. So for finding the domain has to be intersection of all these things. So as you can see that one is x should be greater than -5, another one is x should be greater than +2, another one is x should be greater than -1. So for the intersection, this part will be on the intersection. So the domain of the log function we are using here is anything. Domain is, because it's intersection of all these three things, so the domain would be anything greater than 2. Domain means the minimum of all these three. Domain means intersection of all these three, and this domain, this interval will satisfy for all these three functions. So eventually after solving this equation, if our answer is not one not from this interval, then we're not going to accept that answer. So let's try to combine the log function on the left side, and that can be done by using the product property, which is x plus 5 times x minus 2, and there is a log on the right side. So now we can use the property of equality property of log function. So log base 3, log base 3, so they will be gone. On the left side there is x plus 5 times x minus 2. So I'm going to multiply x plus 5 and x minus 2, which is x square plus 5x minus 2x minus 10, and if you simplify this, it's x square plus 3x minus 10. So we can cancel this log and log, and then it will eventually gives us this value, which is x square plus 3x minus 10, and on the right side this is 2x plus 2. So now we need to solve this equation. This is quadratic equation, so for solving that we are going to bring everything on the left side. So here it will be x square plus x minus 2 half equals 0. So now we can solve this by using the factoring. X -4, x +3 equals 0. Now we need +4 and -3, because 4 times x is 4x, and 4 so it should be +4 and -3, because 4 times -3 is -12, and +4 and -3 is +1. So x, there are two options for x. X is -4 and x is +3. But by looking this domain, we cannot accept anything beyond this domain. So this -4 is outside of our domain. So the answer is x equal to 3 only. Okay, so that's our answer for this problem. We are not going to accept this -4 because it's not inside the domain of the function. Okay, domain of the log function we're using here. So that's how we solve a logarithmic equation. So this is the same problem.